Number one, we have negative square root of 18. Actually, the square root of negative 18, I said that wrong. And we know that whenever we have a negative on the inside, that needs to come out as an I. It's going to be imaginary. So we have an I on the outside. Or if you want to completely show your work, you're going to have the square root of negative 1 times 18. And the square root of negative 1 is I. And the square root of 18 breaks down to the square root of 9 times the square root of 2. Because 9 times 2 is 18. And again, you're thinking, you don't have a perfect square number, you want to break it down with multiplication to get a perfect square number, which is 9. So of course we have I times 3 times the square root of 2. So the only thing you could do is rearrange this answer. You could say that the answer is 3I square root of 2. Or you could even say 3 square root of 2, and you could put the I, but if you put the I at the end, make sure that it's obviously outside of the square root. Some people write the I real close to it. It looks like it's inside the square root. That would not be good. So you could leave it like this, 3I square root of 2, or you could say 3 square root of 2 with an I on the outside. Okay, moving on. Square root of negative 25, what's the answer? 5I. Definitely not negative 5. Negative 5 squared is not negative 25. But 5I squared really is negative 25 if you think about it, because I squared is negative 1. Moving on, number 3. What is I squared? And I to the 12th? 1. Excellent. Right? Let me just show you this picture that we have of the sideboard when we were talking just about i's. So we know that the square root of negative 1 is I. We know that I squared is negative 1. And technically with I squared equals negative 1, you could figure out everything else. Now what do I mean by that? I to the third is really negative I. Now the reason, like if I ask you why is I to the third negative 1? Well, because I to the third is really I squared times I. And that's what I show over here, I squared times I. And we already know that I squared is negative 1, and I is just I, and negative 1 times I is just negative I. I know you're thinking, I. I to the fourth is really I squared times I squared, and we know that I squared is negative 1, and I squared is negative 1, so that's really, if you look over here, negative 1 times negative 1, which is positive 1. So this guy right here is actually very important when you're dealing with high exponents, because all you have to do is divide by 4 and then think about your remainder, and that'll tell you how many i's you have left over. So let's get a little crazy here. How about you guys just give me any huge number? I to the what? 37. Okay, so I to the 37th power. If I think 4 times what gets me close to 37? 4 times 9, right? But 4 times 9 is 36, so what's my remainder? 1. So think about this. I could rewrite I to the 37th as I to the 36 times I to the 1. Now, we just said that this guy right here, it is divisible by 4, which means that I to the 36 is really what? It's really just 1, right? I to the 36 is really just 1 because it's divisible by 34, the power. So it's really just 1 times I, so your answer is just I. Your final answer right there, to I to the 36. Is this starting to make sense? What if I said, what is I to the 14th power? Well, I to the 14th, you could rewrite it as something that 14's, let's say I to the 12th, because 12 is divisible by 4, that's just going to be 1. But how many more i's do you need? You need 2 more, so times I squared. So I to the 12th we just said was 1 because it's divisible by 4, and we already know that I squared is what? Negative 1. So you have 1 times negative 1, your final answer is negative 1. It's that easy. It's kind of like dividing by 4 and thinking about the remainder, and then you could figure that out pretty simply. Now, don't freak out. There's not too much of this on the test, all right? Going back to our class opener here. Number 5, I to the 25th. Is 25 divisible by 4? No. But 4 times 6 is 24. I'll have one more as a remainder, so what's my answer? Just I. Again, the work would be, I would rewrite this as I to the 24th. Why? Because I to the 24th is divisible by 4. And if it's divisible by 4, I mean, in other words, I could write this I to the 24th, I could write it as I to the 4th times I to the 4th times I to the 4th times I to the 4th 6 times. And that would really just be 1 times 1 times 1 times 1 6 times. But of course, I still need this extra I to be able to get my I to the 25th. So I have I to the 24th, which is just 1, times 1I. Well, the answer is just I. Let's go to something more fun where we're actually doing math with imaginary numbers. 3I times negative 4I. It's kind of like saying 3x times negative 4x. That would be negative 12x squared. But in this case, it's not x squared, it's I squared. And we all know that I squared is really negative 1. So I really have negative 12 times negative 1. And negative 12 times negative 1 is 12. And that's it. That's your answer. You see, it's easy. This next one, distributive property. Just pretend it's an x. You have negative 2x times negative 3. It's going to be a positive 6x. But it's really an I. How about negative 2i times positive 2i? That'll be a negative 4 because negative 2 times positive 2 is negative 4. And then I times I is I squared. Now the only difference between multiplying with x's compared to multiplying with imaginary i's is that when you have an I squared, you have to replace it with a negative 1. So far I have 6i minus 4 times negative 1. You replace the I squared with negative 1. So you really have 6i, negative 4 times negative 1 is a positive 4. And of course, this is still not written correctly because you always want your complex numbers that we learned about yesterday with the real part first and the imaginary part second. So my final answer would be 4 plus 6i. You got it? I hope. Number 8, we're subtracting. It's just combining like terms, guys. Go ahead and distribute that minus sign. You have a minus 3, a minus I. Bring down the 2, the plus, the I. So you have 4 terms right there. Let's combine the numbers with the numbers, the real part first, because on complex numbers, you want your real part first. I have 2 right here, negative 3 right here. That's going to be a negative 1. And then what about the i's? You have a positive I and a negative I. What happens? Cancels out. That's it. Your answer is negative 1. Moving on. Number 9, we're adding, combining like terms here. All right, so there's, even if I distribute the plus sign, it's not going to change anything. So I might as well just start combining. What is 2 plus 3? 5. That's right, 5. Okay, and then how about negative 3i plus 2i? Negative 1i. Now you don't even need to put the negative 1. You could just leave it as negative I. So your final answer is 5 minus I. Got it? Now for the fun part, distributing, where you have a binomial times a binomial. Number 10, 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times 2, that's positive 6i. 3i times negative 3i, that's negative 9, what? I squared. And that I squared is very important, because we're going to have to change that I squared to a multiplication of negative 1. But let's combine like terms. So I'm going to combine the negative 6i with the positive 6i. And what happens? Cancels out. So I end up with 4 minus 9 times negative 1 instead of I squared. So that's really 4 plus 9, which is 13. As a final answer. Notice that the i's disappeared. They canceled out. Number 11. Let's do it. 1 times 1 is 1. 1 times I is positive 1i. Negative I times 1, that's negative 1i. And then negative I times positive I, that's going to be a negative I squared. Again, the middle values cancel out. What do I have left? Well, I have this 1 out here in the front. I have minus. And instead of I squared, instead of this I squared, what am I going to write? Negative 1. So what's my final answer going to be? 2. Because 1 plus 1 is 2. Again, the i's canceled out. Let's check out number 12. 3 times 3 is 9. 3 times negative 5 is negative 15 with an I. And then positive 5i times positive 3, that's positive 15i. Positive 5i times negative 5i, that's going to be negative 25i squared. The middle values, again, cancel out. I have 9, I have minus 25, but instead of I, I'm going to write, instead of I squared, I'm going to write negative 1. So I really have 9 plus 25, so my final answer is 34. Now, on all these three distribution, binomial times a binomial, on all three of these, all the imaginaries canceled out. What could you tell me about the first binomial here compared to that second binomial? It's the exact same thing except what? This is a plus sign, that's a minus sign, except for those middle value signs. In other words, except for the sign of the imaginary value. They're opposite. And that is true for number 11. The imaginary value signs are opposite. The real numbers are the same, but the imaginaries are opposite. And it's the same thing for number 12. The imaginary part signs are opposite. Now, that's not a coincidence, guys. When you have the same exact binomial and that middle sign changes, it cancels out all imaginary values. Now, it has to be the same exact binomial. So if for some reason I had like 2 plus 3i, and then 5 minus 4i, and I distributed, the i's are not going to cancel out. All right, the i's will not cancel out right there. It has to be the same exact binomial for it to cancel out the i's. So if I had a 2 plus 3i, I'd have to multiply by 2 minus 3i, and that would cancel out i's. Okay? So this is called the conjugate. Let's go back to our notes from yesterday. Listen up, guys. It says the conjugate. This is a vocab word that we all need to know. Conjugate. The conjugate of a complex number. Remember, a complex number just has a real part and an imaginary part. The conjugate of any complex number is simply going to be that same complex number, but you change the sign of the imaginary value. That is the conjugate. Okay? Now, I want you to practice rewriting the conjugate of each of these complex numbers, assuming that they're complex numbers. So what would be the conjugate of number 1? 3 plus 2i. Okay, go for it. Do the rest. So I hope you took the time to do that, and now you could see right here the actual conjugate. Notice that the real part, the 3 is still a 3, the 5 is still a 5, the 0.5 is still 0.5. Nothing changes except the sign of the imaginary part. The negative 2i became positive 2i. The plus I became minus I. The minus 4i became plus 4i. That is the conjugate. Now, if you get down here to number 6 and 7, these are kind of tricky because you can't really see it as a complex number. What's the real part of number 6? The real part of number 6. If you wanted to force a number right there to be the real number part. 0. So 0 minus 3i is what you really have, which means that the conjugate of 0 minus 3i would be 0 plus 3i. So the conjugate of negative 3i is really just positive 3i. Of course, you could put a 0 in the front if you want. Okay? And last but not least, number 7, there is no imaginary part. So if I say, what's the conjugate of 9? It's just 9. Because there is no, it's not even a complex number, it's just a regular number. So we only have about 25 seconds left. We are going to do another video that shows how to use the conjugate to get rid of imaginary values in the denominator. Okay? So we're going to use the conjugate to get rid of these imaginary values in the denominator.